Bismillah Rahman Rahim. In this session, we will discuss exam style questions from section 4.4 Practical Electricity under the subject of O-level physics from the book of Tom Deakin and Heather Kennett, published in 2021 from publishers are Orders Education, and this topic is very important. And here we are discussing the first question, that is there are hazards in using main electricity supply. Identify two factors which can increase the risk of fire in circuits connected to the main supply. So if we place any inflammable material too close to the hot appliances, it may catch fire, such as electric heater. If we place any flammable material close to the electric heater, it may catch fire. And similarly, if the electrical wiring is in the wall of a house becomes overheated. So there are wires, if we are overloading the wire, it may catch fire. So there are two reasons, and these factors have discussed here. So identify the two factors which can increase the risk of electric shocks. Electric shocks occurs if the current flow through the electric circuit through the person's body to the earth. So if any person touches a live wire and have a path from which the current through the body to the earth, then the person gets electric shock because the current flow through the body. So it usually happens because of the damaged insulation. If somewhere a damaged insulation, that as a result of that, it conducts and it becomes live wire. So that live wire, if anybody touches the live wire in absence of insulation, he may get electric shocks. Similarly, if faulty wirings, the wirings are improper, it may also give electric shocks. So describe the steps, part C. Describe the steps you would take before replacing a fuse blown in appliances. In many appliances, due to the overloading or switching or fluctuations, fuse may blow. Now above maybe aging, the fuse may blow. So before replacing the fuse, we should take some precaution measures. A fuse protects a circuit. It is always placed in the live wire. Fuse are always placed in the live wire, and always switch off before replacing a fuse. If you want to replace a fuse in any circuit, that circuit should be offline or its switch must be off. So before replacing the fuse, it should always be switched off. Its power supply must be switched off. To avoid the risk of electric shock, to avoid the risk of getting an electric shock, following steps should be taken. Switch off the electrical supply to an appliance before starting repair. If you want to do some repair work on any appliances, it should be isolated. Means the power supply to that appliance should be off. Use plug that have an earth pin. So always use plugs, 3-pin plugs with the earth wire connected and a cord grip. So a rubber or a plastic case is preferred. So if an earth pin is attached or properly connected, in case of any fault, there will be or any leakage current that would draw out through this earth pin, and the user will not get any electric shock. Third, do not allow appliances or cables to come into contact with water. The cable and appliances should not get any contact with the water. Because of moisture, the resistance may drop or it may be dangerous. So for example, holding a dryer with wet hand in a bathroom can be dangerous because the resistance will be dropped drastically. So the high current may flow. So keep electric appliances well away from the baths and swimming pools. So we should always take electric appliances from the water. So don't have long cables trailing across it. So we should not use a long cables because of this long cables, it may come across areas where rubbing and other frictions may damage the insulation, and it could be injurious to the person that may come across and get the electric shocks. So this is all for this part. Now part D, why an electric appliance is double insulated or outer case is earth. So in case of many equipments such as vacuum cleaner, hair dryers and food mixers are usually double insulated because the connection to the supply is by two core insulated cables, no earth wires. So in case of absence of earth wire, that appliance should be enclosed in a non-conducting plastic case. If the appliance or the electrical part is enclosed in a non-conducting plastic case, if the wire or anything that connect to the motor or any electrical part of the equipment, this plastic case will act as the insulation, and there will be no electric shocks as a result of, due to this plastic casing. So this plastic casing helps the user to get the electric shock. So double insulation and this non-conducting plastic casing may prevent the user from the risk of electric shocks in case if there a fault develops. Now we are showing some electrical connection in a house. Suppose this is the supply from supplying company inside the house. It passes through a main fuse. This is main fuse is on the live wire. L is the live wire, N is the neutral, and that wire goes to the meter, energy meter, and from there it comes to the switchboard. And this switchboard, we have a live wire and a neutral. From this live wire and neutral, we extend it to the different supplies. Suppose this first supply goes to this lighting circuit, and this live wire and this neutral wire, and between this live and neutral we have some lighting circuits, and we have some switches. Here we have a double switch. In this way we can switch off this circuit from either side. In the next one we use this for the immersion heaters, or this comes to the main ring circuit, and from this ring circuit we have some earth wires as well, and this earthing wire is always in a socket, comes in a socket where we use for the refrigerators or heaters or toasters or electric kettles. So for this we use these sockets, and that point is the bigger point is the earth point, and it prevents the users from getting any electric shock in case the fault develops or the insulation damage. So this is all electric circuit in a house. This is a typical house. And earthing, a main ring main has a third wire which goes to the top socket on all power point. Here this is the ring main, and here we have 3 rings. This is live wire ring, this is the neutral ring, and this third dotted ring is the earth ring. And the earth ring is contacted with this one, and the neutral ring is attached with this neutral part, and this live wire is connected with the live part. So this is simple, very easy to remember or memorize. And earth is being connected either to a metal water pipe entering the house or to an earth connection on the supply cable. Usually we connect to the supply cables or any metals connected to the ground or earth may be used. And this is the way the electric supply to any common house may be used. Fuses are widely used in electric circuit connected to the main supply. A fuse protects a circuit, is always placed in the live wire. Fuse are always placed in the live wire for the protection purposes. It is a short length of wire of material with a low melting temperature, often tinned copper, which melts and breaks the circuit when the current in it exceeds a certain value. If the current crosses its limit, then this fuse blown and save or protect the circuit. So for 2 reasons of excessive currents are short circuit due to the worn insulation. The 2 reasons for excessive currents are the short circuit due to the worn insulation or connecting wires and overload circuit. So if insulation gets damaged, then a short circuit happens, or in case of overloading, more current draws, and that causes this kind of problem. So without a fuse, the wiring would become hot in these cases and could cause a fire. The fire should ensure that the current carrying capacity of the wire is not exceeded. So a fuse ensures that the current capacity of the wiring is not exceeding. So it's an insurance, it's a guarantee. So if the limits cross, then this fuse blown to protect the wire. So this is important. So we actually place the fuse according to the requirement. For heavy loads we use a thicker wire. For small loads we use a very thin wires. So part B, the circuit of a figures 4.48a and B shows short circuited between the live and a neutral wire. In both the fuse has blown, but whereas the circuit A is now safe when B is still dangerous, even though the lamp is out, which suggests the circuit is safe. Explain. So here we have these 2 circuits. This is the live circuit, this is a live wire where a fuse is placed on a live wire. In a second, the fuse is placed on the neutral wire, and this is the load, and a short circuit develops here. Similarly, the short circuit develops here across a load. It bypasses the load, that's why it's called short circuit, and as a result of this short circuit, this fuse will blow, and this on blowing this fuse, this live wire will not be applied on this appliance. But in case of this, if short circuits, this fuse will blown, but as a result of this fuse blown, this live wire will be applied here at this point, and it could be dangerous. So this A is the safe one and this B is unsafe. So that's why the fuse is always placed on the live wire. So because the fuse is connected on the live wire in figure A, therefore a fuse breaks, the circuit is open as a result of short circuit. On the other hand, in figure B, the fuse is connected on the neutral wire, therefore after the fuse break, the live wire is still connected with the lamp. This live wire is still connected with the lamp, which is unsafe. So it is concluded the Fuse is always placed in the live wire for protection of the appliances and electrical circuits. This is question number 3. A child whose hands are damp touches a wire carrying electricity at 240 volts. The resistance of the child's skin between hand and earth is 800 ohms. Calculate the current which would flow through the child. The current flow through the child will be I is equal to voltage upon resistance. So here we will get 0.3 ampere. So state whether the current you calculated in part 1 is likely to be lethal. Yes, because this is 300 milliampere, and 0.1 ampere or 100 milliampere is a lethal current. State how the current should be reduced. High insulation resistance wire should be used. Any wire should be covered with a high insulation. Avoid touching switches or wire under damp condition. So in case of wet condition or wet hand, everyone should avoid touching the switches. Avoid working with the live wire of the circuit. If it's really necessary to work on a live part, use a proper gloves. So use a proper glove if necessary to work on a live part of the circuit. So this is the way that current could be reduced. Work out the size of the fuse which should be used in the following appliances if the supply is 230 volt. For 150 watt television, current is 0.65 ampere, so 3 ampere fuse is suitable. For 900 watt iron, current is 3.91 ampere, so 13 ampere fuse is suitable. For 2 kilowatt kettle, the current is 8.69 ampere, power divided by voltage, so 13 ampere is suitable. So that's all from section 4.4. In the next section we will discuss section